Welcome back. We're going to continue our discussion on chemical bonding, and the first type of bonding we're going to look at is ionic bonding. Now let's look at the criteria. Now if you see, for a bond to be ionic, we can also prove this from the Linus-Pauling electronegativity table, which we're going to look at pretty soon. But if you have a metal and a non-metal combination, there's a higher chance it's going to be ionic bonding. But could that be any metal? No. The metal has to be either alkali or alkaline earth metals. Okay, that is elements under column 1A and column 2A, except hydrogen, because hydrogen is not a metal, it's a non-metal. But it is under column 1A because its atomic number happens to be 1. So anyways, if your metal is alkali or alkaline earth metals, and if it is any one of the non-metals, then the resulting bond is ionic bonding. And as I've always said, metals always make a cations, that is, it loses electrons and it's positively charged, and non-metals in an ionic bonding can be a single negative ion, which is what we're going to focus now, or it can be a collection of elements as a poly-negative ion or polyatomic ion, which we are going to reserve for later when we actually talk about naming compounds. I think this fits there more than right now. Okay. Convention, for instance, your metal can be, say, A. If A is your metal, it's 1 plus, or A can be 2 plus if it is alkali or alkaline earth metals. Okay, so there's only two types of metal charges you can expect. If it's alkali means it's 1A, means you can lose 1 electron. Alkaline earth means it's 2A, so you can lose 2. Or it can be a non-metal, which can be, 1 minus or 2 minus. I'll explain this in just a second. But what I mean by a single ion is there's only one element, okay? All right. Now let's say, what ions can sodium make? Can it make a +2? No, because sodium is 1A, so it will make only Na1+. What about calcium? Well, calcium is in 2A. So calcium is a metal and it's an alkaline earth metal. So metals can only lose electrons, and alkaline and earth metals and alkali metals lose all of their valence. So calcium would lose the 2 valence electrons, so it will make 2+. Now all of these can also combine with any of the non-metals shown. So nitrogen, I've repeatedly said, nitrogen's valence number is 5. Yes, it's got 5 valence electrons. But what did I repeatedly say? It cannot use 5 valence electrons for bonding. You would have to have 8 minus 5, that is 3, means N is 3 minus. Because it's a non-metal, the negative charge is default. What number goes in front is very, very important, and the only way we get that is here. Okay, why? Because nitrogen is a non-metal. Oxygen is, sorry, this should be B. And this should be 6B. So with non-metals, they don't use all the valence electrons. They actually gain electrons from the element it's pairing with. And how many it gains depends on which element it's pairing with. But typically, the only way we can get that number without actually pairing is actually take 8 minus 5, and this is foolproof. So it's 8 minus 6 is 2, so oxygen is 2 minus. Now this is what I mean by a single element and an ion. Single negative ion is this. So let's say chlorine, okay, that is 7B, okay. So 8 minus 7 is 1 electron. So Cl is negative, it's a non-metal, so it's negative, but what number do you put in depends on whatever you get out of 8 minus 7, which is 1. Now, this is rarely explained on how people get this charge. Typically, this is shoved under the carpet most of the time, And they usually start with naming compounds, and people cannot find a way to concretely understand this, okay? Which is why I'm taking the time to actually explain how these have come about. So the next screen, you're going to be pleasantly surprised. You're just going to do it like it's a piece of cake. All right, let's move forward. Now, let me put all this over here. I want you to write the formulae for ionic compounds. Okay, I'm going to teach you a couple, and then the next screen, I'm going to give you some practice to work on yourself. Now, as I said, ionic compound means that the metal has to be alkali or alkaline, and then the anion has to be a single anion. For now, we will look at polyatomic later. Now, keep in mind, this is not a name. Please do not go tell some outsider that if someone gives you NaCl, don't say sodium plus chlorine. They're going to think badly about me, that I've done a terrible job. All right? This is a way to get things started. All right? So if these were to combine, what is the formula? Well, sodium is an alkali metal. And whenever two elements combine to make a compound, they don't exist as elements. They make ions. I mentioned that in the introduction to periodic table video. Sodium is an alkali metal, and its valence is 1A, so it's 1 plus. Cl is a non-metal, and it's in 7B, so it's 8 minus 7 is 1, so 1 minus, right? Now, well, it's 1 to 1, so all you got to do is write them together because they cancel out. Now, do you see how NaCl can only be in this form, not any other form? Because of the understanding I've explained in the previous video. All right, calcium. Calcium is an alkaline earth metal, so it's 2A, 2A, so it'll be 2 plus because it's a metal. Oxygen is a non-metal, so it's negative. But what number goes in front is, well, it's 6B, right? Oxygen is 6B, right? So it's 8 minus 6 is 2, so 2 goes here. So happened, this is plus 2 and minus 2, no problem. Just combine them without any number, CaO. When the numbers are identical, just cancel them out and combine them together. Again, I have not exactly told you what the names are. These are not names, okay? The reason I'm teaching you this way is very beneficial for doing a lot of chemistry related things, all right? Now let's combine calcium and nitrogen. Well, calcium is still 2A, so it's 2 plus. Nitrogen is, well, I just mentioned that in the previous video and videos before that, it's 5B, so 8 minus 5 is 3. So it's negative, but the number is 3. Now comes the case. How do we combine when the charges are inappropriate? All you do is you simply cross swap them, okay? Bring the 3 below the calcium and bring the 2 below the nitrogen. And there you go. Which what is unique and exciting about chemistry is the same calcium has a completely different identity depending on what it is combining with. When it combined with O, it had a different formula, whereas when it combined with nitrogen, it had a different identity. Same element. Shouldn't it always be making like, you know, even out and then have the same situation? No, that's what's fascinating, and that's what creates all these compounds. And all these are ionic. Why? Because we got a metal and a non-metal. Let's do the last one. Lithium is in group 1A, right? And alkali metals loses all of their valence, so it's 1 plus. Sulfur, well, sulfur is same as the same column as oxygen, so it's 8 minus 6 is 2. Sulfur is a non-metal, so it's negative. The 2 goes in front. Now we see that they're not even, so the 1 comes out here and the 2 comes out here. Well, you don't need to ever write the 1, so Li2S. You don't need to write the 1. And this is very, very important for 2 reasons. First, we are actually understanding how ions combine through our knowledge of valence electrons. We're not doing this like a regurgitated or more memorized based aspect, which I hate. We're actually learning how things work. And I'm going to leave this end of this video with, I want you to combine these and actually write the compound of these ionic compounds. Keep in mind, these are not names. This is just how elements are combining, and I want you to write the formulas for these compounds. All right, just practice. And in the next video, I'm going to be coming back and talking to you about Linus Pauling electronegativity table and how there are other ways to identify bonds, which are much easier. All right, so stay tuned.